Alright, this is section 11.4, circumference and arc length. The first part here, circumference, is probably familiar to you, so I'll go through that pretty quick. The circumference is the distance around the circle. Okay, it's not the area of the circle, it's the distance around the circle. Okay, so if I want to find that distance, I've got two formulas. Either the circumference equals 2 pi r, or circumference equals pi times the diameter, d. Okay, I personally prefer the top formula there, 2 pi r, but pi times d is exactly the same thing. Just generally, more often than not, we're given r. So let's find the circumference when the radius is 9. Well, I'm going to use that first equation, c equals 2 pi times r, except r is 9. So 2 times pi times 9, I could leave that as 18 pi, and that would be fine. Oh, come on, load. I could leave it as 18 pi, or I could call estimate it and round to about 56.5. Okay? Centimeters. And it's just centimeters, not centimeters squared, because it's a length. Okay, so we want to find the radius when the circumference is 26 meters. Well, in this one, I know that c is 26, so 26 equals 2 pi times r. I want to solve for r. And I apologize that it's taking so long to load. There we go. Solving for r, I'm going to divide both sides by 2 pi. I can do that all in one step. Divide both sides by 2 pi. On the right, 2 pi's cancel out. And on the left, if I kind of round that, that's going to end up being r equals 4.1 centimeters. Okay, and that's how we use that formula. Like I said, it should be pretty familiar, I think. Let's go down to the arc length corollary. In a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the arc to the measure of 360. So when we talk about arc length, we're talking about, no longer are we talking about measure, right? That was measured in degrees. When I say arc length, I'm talking about the actual distance to get from A to B. If I was walking along this path in red here, A to B, that would be the arc length. Okay. So my theorem corollary says arc length of AB over 2 pi r, which is the circumference, so 2 pi r. So arc length over 2 pi r equals the arc measure, so the measure of AB, divided by measure of arc AB divided by 360. Alright. So the arc length, that fraction of the circle divided by the circumference, and that fraction, kind of the measurement of the angle or the degrees of that arc divided by 360. Let's see how it works. Over here, in the first example, I'll try and write around that. In the first example, I need to, I want to find the arc length. So I want to find AB. Well, I know that the actual length of AB, now I'm just going to write AB, but we have to kind of agree with each other that we're not talking about a line here. We're talking about the length of AB, okay? AB over 2 pi r. Well, r in this case is 8 centimeters, so 2 pi r equals the angle measure, the arc measure, which is just AB, is going to be 60 degrees, divided by 360. Oh, I'm sorry, and we know r. R is 8. I guess I should have written that in there. 2 times pi times 8. Okay? To solve this, we're going to have to cross multiply. Right? So I'm going to take 2 pi r times 60. And then I'm going to take AB times 360. And this is really just a one-step deal here. Once you kind of, well, maybe 2 steps, and you get down to AB, you don't want to really waste your time with the algebra here. AB equals 8.4. Remember, that's the length of AB. That's this length right here. Okay? Let's go to the next one. In this one, I've got a very similar situation. In fact, I've got almost exactly the same situation. So why don't you try this one on your own? Once again, I've got the radius, I've got the angle, or the arc measure here. I'm trying to find AB, and I'm going to use that same proportion. All right. So let me bring up the next set of notes here, the next screen. Okay. As we move down the page, things get a little bit more tricky. All right. In this one, oh, I'm sorry. The indicated measure is the circumference. You guys can probably write smaller than me. I want the circumference. Okay. So I want the distance all the way around. Well, in our little formula, if you look in the box right above it, that 2 pi r, we can just substitute that with c, the circumference, right? Because 2 pi r is the circumference. So my theorem would go something like this. xy, remember that's the length of xy, right? The length of that arc, xy, divided by c. All right, now I've changed it from 2 pi r to c because I'm just looking for c, equals 40 divided by 360. Okay? Equals 40 divided by 360. Oh, and so I'm gonna instead of rewriting this whole thing, well, I guess I'll rewrite it. So xy is 4.19 divided by c equals 40 over 360. I'm going to leave that as 40 over 360 as a fraction, not simplify. To solve this, I would cross multiply, right? I'm going to take c times 40, 4.1 times 360, and you should get down to c equals 37.71. Okay? Alright, in this one I want to find the measure of the arc xy in the next example. Okay, find the measure of the arc xy. So we'll see real quick here that I've got the radius, good. I've got the arc length, good. I know the whole thing is 360, so I'll just have to solve for xy. I'll set this one up for you. You guys can finish it. So my theorem says this, the length of xy, so I'm just going to call that xy, divided by 2 pi r. Well, that's going to be 2 pi times r, which is 15.28. Come on. That's going to equal 2 pi times 15.28, and that's going to equal the arc measure. That's what I'm looking for. The measure of xy. Remember, that's that thing measured in degrees. Measure of xy divided by 360. Okay, and you can solve that. I think also we're given xy is 44, so I'd substitute 44 in for xy. Okay. And that's all. Let's move down to the next example here. Find the indicated measure. Very similar situations. Except in this one we don't know what the heck is labeled 9 yards. and I don't know what I'm looking for. Okay, we're going to skip that example and go to the last one here, where I know a little bit more about, sorry, bad example, a little bit more about what's going on. In this one I want to find the radius of f. So find the radius of circle f. Okay, find the radius of circle f. Well, I know that I've got the arc measure, I've got the arc length. I think this will be pretty straightforward. Once again, I'll set it up. You can practice your algebra skills. And so the arc length is 10.5 divided by their circumference, which is 2 pi r. Well, we're looking for r, so 2 pi r. Set that equal. I know it's loading. Don't worry, it'll come. It'll show up. There we go. All right. Okay, 10.5 over 2 pi r equals the measure of that arc. Well, that's the measure of the arc in angles is 150, in degrees is 150, divided by 360. Okay. And then, once again, cross multiply. When I do that, I'm going to get 2 pi r 2 pi r times 150 equals 10.5 times 360. Okay. Which is going to end up being, let's see, 300 pi r. Set that equal to 10.5 times 360 is 3780. And then we could divide by 300 pi and so on and so forth and solve for r. You should get down to r equals 4.01. And that's feet. Okay, so hopefully you found this section a little bit more straightforward than the other ones. That's pretty much it. If you can kind of master those couple types of examples, then you should be good for this section, and we'll see you tomorrow in class.